So for page 92, this is just more practice from page 91, solving exponentials or exponential equations. So you can just put practice up here. This is what it's going to look like in the end. So we've got 8 examples to do, so it's kind of crowded up here, so you're going to have to write small. We're actually going to start down here at the change of base formula. I talked on page 91 about the change of base formula, so I'm going to do that first. So technically, I guess you could put it up here at the top if you prefer, but I'm going to come down here and start down here first. So, in the solving equations page on the last one, I said that you could use whatever base that you wanted. So for the change of base formula then, this is going to show you that regardless of the base that you have, you can actually change that base to whatever you want. And so, for example, if I have log base b of a, that's equal to log base c. C can be whatever I want as long as it's positive and as long as it's not equal to 1. And so the a, the argument, stays as an argument at the top. The base that I had to begin with will become the argument of the denominator, and that base of c will remain the same on both of them. So I'm changing my base from a b to a c. I'm going to leave my argument in the numerator, and I'm going to leave my base as the argument in the denominator. So I've got that same exact example that we used on the last page, log base 3 of 8. We said that it was the same thing as log base 10 of 8 divided by log base 10 of 3, which actually we showed was the same thing as natural log of 8 divided by natural log of 3. But if you have the black calculators, or if you have Desmos, you can type this in, log base pi of 8, and divide that by log base pi of 3. You would actually end up with the same answer of that 1.89 we got earlier. Or if you simply did log base of 1,000 of 8 divided by log base of 1,000 of 3, you would actually get the same thing. So regardless of which of the bases that you use, 1,000, pi, natural log, or 10, they all give you the same answer of log base 3 of 8. Now, let's come back and do some of these examples then. So I told you we have a total of 8 examples, so we'll start now with our first. So in this first example, remember there are 3 examples here that go straight across, so give yourself some room here. I'm going to start with 2 to the 3x minus 4 equals 8. This exponential has been isolated already, so remember that you ask yourself if you can change them to the same base. If so, you do so. So this has a base of 2, and I can change this 8 to a base of 2 as well by making it 2 cubed. So that's where I'll start. You now have 2 to the 3x minus 4 equal to 2 to the third. These bases now match, which means their exponents must also match. So we'll now do step 2, which said to take the exponents and set them equal. So 3x minus 4 is equal to 3. I'll add 4, divide by 3, and my answer is x equals 7/3. I could plug that back up here just to make sure that it works. So 3 times 7/3 is going to be 21/3, which also is 7. 7 minus 4 is 3, and 2 to the third power truly is 8. So we know we have the right answer. For example 2 now, we have 4 to the x equals 1/8. Since both the 4 and the 1/8 can be changed to a base of 2, that's where I'll start. So 4 is the same thing as 2 squared. 1/8 is the same thing as 2 to the negative 3. And so now I'll multiply these two exponents to get 2x. So we have 2 to the 2x equals 2 to the negative 3. Set the exponents equal. You have 2x equals negative 3, which means that x must be equal to negative 3/2. Again, you could plug that in, but I'm not going to check that they're correct. Example 3, we have 3 to the x plus 1 equals 9 to the x minus 2. If you want, you can go ahead and pause the video at this point and see if you can do it on your own. If not, that's fine too. So the base of 3 and 9 can be set equal by making this 9 a 3. So 3 squared is the same thing as 9, so we have 3 squared raised to the x minus 2. I'll multiply these two sets of exponents here using my properties of exponents. So I get 3 to the 2x minus 4 when I do that, and I set that equal to 3 to the x plus 1. Now those exponents can be set equal to one another because the bases are 3. So we have x plus 1 equal to 2x minus 4. We'll subtract x from both sides, so that'll give me x equals. We'll add 4 to both sides, and that'll give me x equals 5. If I want to plug that in, I would say 5 plus 1, whatever 3 to the 6th is. I would check to make sure that's the same thing as 9 cubed, and if you plug that into a calculator, they will give you the same answer. For example 4 now, we have 3 to the 2x plus 1 minus 5 equals 4. As of right now, we need to isolate this exponential first, so we'll add 5 to both sides. That gives me 3 to the 2x plus 1 equals 9. At this point, if you want to pause the video and try the rest of this example on your own, you definitely can do so. We'll change this 9 to 3 squared. Now the exponents will be set equal to each other. Solve for x, and we end up with x equals 1/2. For example 5, we have 4 to the x plus 3 equals 7. For this one, 4 and 7 are the bases. They cannot be set equal to each other in any way. So at this point, I'm going to take either the log of both sides, the natural log of both sides, log base, whatever you want of both sides, because the change of base formula says that we can use whatever base that we want. So when I do that, I just simply took the log of both sides. This has a base of 10. And so now that exponent, using our power property of exponentials, of logarithms, I'm sorry, power property of logarithms, can come down in front to become x plus 3. We have times log 4, and then it's equal to log of 7. I'll divide both sides by log of 4 in order to solve for x. Then I'll subtract 3. Once you get that as your answer, you'll use your calculator to get some decimal if it's allowed. If it's not allowed, then you would just leave this as your final answer on a quiz or a test. Now for example 6, we have 3 to the 2x plus 1 minus 5 equals 11. I would suggest that you pause the video at this point and try it on your own, because you can definitely do this example without me. To begin, we'll add 5 to both sides. We get 3 to the 2x plus 1 equals 16. We'll take the log of both sides. This time I chose the natural log. So now I'll bring that 2x plus 1 down in front, multiply that by natural log of 3, equal to natural log of 16. I'll divide both sides by natural log of 3. Then I'll subtract 1 and divide by 2. Now, instead of dividing by 2, I'm going to choose to multiply by its reciprocal. And that reciprocal in this case is going to be 1/2. And so when I do that, my final answer is x equals 1/2, parentheses, natural log of 16 divided by natural log of 3 minus 1, and all this in parentheses. And then at this point, you could again use your calculator. And when you do that, you get 0.762 approximately. Now, example 5, I actually had the calculator answer to this. It was negative 1.596. And then, I know this is kind of weird, we're actually going to do number 7 now. I'm going to leave number 8 for class because it's actually a very hard example, so I prefer to do that one in class. So please don't do that one without me. But because it took up so much room, it takes up a lot of room in order to do it, I moved it over here on the left, and I've got my number 7 over here in the middle instead. So again, leave number 8 for class because it's pretty hard, and we'll do number 7 now. So for number 7, we have 1/3 e to the 2x plus 1 equal to 10. I need to isolate this exponential first, so I'm going to multiply both sides by 3. So I have e to the 2x plus 1 equals 30. At this point, I could choose whatever log I want, log base 10, log base 3, and so forth. But I'm purposely going to use natural log because log base e or natural log and e will cancel each other out. So I'll take the natural log of both sides. When I do that, remember natural log and e are inverses, so they'll cancel one another out, and I'll get 2x plus 1 equal to natural log of 30. We'll subtract 1, divide by 2. And so when I do that, if you put it into your calculator, you end up with approximately 1.2. We'll do number 8 in class, and so now for this page we're completely done.